Example 2a, this is the printed problem. We're asked to expand x plus 1 all raised to the fourth. And so, first of all, let's use what we learned in the warm-up about the patterns with the exponents. And x is going to start with a power of 4, and then it's going to go down until it's power of 0, and then the 1 is going to start with the power of 0 and go up until it's a power of 4. So x is like our A and 1 is like our B if you're trying to match it up with what we did in the warm-up. So I'm leaving space here for the coefficients, because we're going to use the binomial coefficient or the binomial theorem to fill those in. But see how so far I've just laid out the exponents, with the x's going in descending order with their powers and the 1's going up in their power. Okay, so in order to figure out what these coefficients are, since it's raised to the fourth power, that means we start with 4 above 0, then this one's going to be 4 above 1, 4 above 2, 4 above 3, 4 above 4. And then I am fine with you using the calculator to calculate those. And so again, the way you do that is math, probability, number 3. So 4 above 0 is 1. And so each of those creates the coefficient that you're going to have. And that is the answer. That's that. So try your pencil problem. I actually think, I want to do this pencil problem with you because it just kind of has an extra step. Looking at pencil problem 2a, we want to approach it the same way. So starting with the powers of the exponents. So we'd start with x cubed times 2 to the 0, x squared times 2 to the 1, x to the 1 times 2 squared, plus x to the 0 times 2 cubed. But we're missing the coefficients. And so we use our binomial theorem. So this is 3 above 0, 3 above 1, 3 above 2, and 3 above 3. So when you calculate those values, our next line would look something like this. And what's different about the last problem is, on the last problem, these were 1s. Where we have 2's now, we had 1s, and so they were basically not mattering. But now that it's a 2, they are affecting the final answer. See, because on this second term, we have 3 times x squared times 2, so that's going to be 6x squared. This third term is going to be 12x. So that's your final answer for this pencil problem. Example 2b. So we want to start again by just looking at the terms inside of here. The x is going to be the one that starts with the exponent of 5 and goes all the way down to x to the 0. Negative 2y, and you do need to include the negative as you do those exponents. Negative 2y is going to be the one that starts with 0 and ends with being raised to the 5th power. Now, to figure out the coefficients, we use our binomial theorem. So this is 5 above 0, 5 above 1, 5 above 2, 5 above 3, 5 above 4, and 5 above 5. So then when you calculate those, see, those are the purple numbers. And then also notice, like, negative 2y to the 0 is 1 here. Negative 2y raised to the first power is negative 2y. But when you square it, it's positive 4y squared. When you cube it, it's negative 8y cubed. When you raise it to the fourth, it's positive 16y to the fourth. And when you raise it to the fifth, it's negative 32y to the fifth. So this is going to be alternating. these terms are going to alternate in signs when you clean this up. So for example, this second term here is going to be negative 10 x to the 4th y. So that's your final answer. I want to do pencil problem 2b with you also, because one of our terms inside the parentheses has an exponent on it, so I want to make sure you're good with that. So we start with the, actually I already wrote in the 4 above 0 stuff, but if you look at what I have in green, we're doing x squared is starting with the power of 4, then power of 3, then it has a power of 2, 1, all the way down to 0. My 2y is starting with the power of 0 and ending with the power of 4. And then for your coefficients, you have 4 above 0, 4 above 1, so on and so forth. And so then we're going to calculate those, and once again, I'm fine with you doing that in the calculator. And then simplify each term. Keep in mind when you multiply a power to a power, which is what you're doing here, like x squared raised to the 3rd, that's x to the 6th. So a power to a power, you multiply. So go ahead and write this formula in your notes. So I'll let you pause the video. Okay, so let me explain this. This is if you're just looking for a particular term of a binomial expansion. And this is the formula for that. And I want to show you where this is coming from. You think about what we just did. So like right here, this is for the second term. We had to do 4 above 1. So like if we're looking for the second term, then we're going to want to plug in r as 1, and that's why it tells you to do that. So if we're looking for like the 5th term on a problem, we're going to plug in r as 4 on this. And that's the main thing you need to understand to be able to use this formula. So example 3, we're going to find the 5th term in the expansion of 2x plus y quantity raised to the 9th power. So we're going to be using this formula that you just wrote down. And remember, a is the first term that's in your parentheses, and b is the second term. So our n is 9. N is always the power that's out here. And if I'm looking for the 5th term, I want to plug in r is 4. So a is 2x, and then b is y. That's just coming from right here. So that's everything we're plugging in. So we have 9 above 4 times 2x to the 9 minus 4 times y to the 4th. And so this is, of course, just 2x to the 5th. So that part is going to be 32, x to the 5th. This is just going to be y to the 4th. And when you punch that in the calculator, you get 126. And then just simplify all that, and that's your answer. Pencil problem 3. We're looking to find the 6th term in the expansion of x squared plus y cubed all raised to the 8th power. So once again, if we're just looking for a specific term, then we can just use this formula. My n is going to be 8. My r, since I'm looking for the 6th term, is going to be 5. And my a is x squared. My b is y cubed. So plug all that stuff in. And so right here, we're really doing x squared raised to the 3rd, so that's going to be x to the 6th. So then that's your answer, 56 x to the 6th.